Hey everyone, you ever look up at the stars and think about some of those classic space puzzles? Well, there's one question that comes up all the time, and today we're going to dive right in and solve it.
So here it is, the big question. How on earth does a rocket move in the total vacuum of space? I mean, think about it. There's no air, no ground. There is absolutely nothing to push against. It just feels like it should be impossible, right? Well, the answer is actually way simpler and honestly kind of beautiful.
And let's get one thing straight right off the bat. Whatever you're thinking, the answer is not that they push against air. In fact, that's the key to this whole mystery.
Yeah, this idea is so common, we're just going to call it the Great Space Myth. And in this first part, we're going to unpack this exact misunderstanding.
So let me be crystal clear. The idea that a rocket needs air to push against is totally 100% false. And here's the crazy part. The lack of air actually makes a rocket more efficient. So how is that even possible? To get it, we don't need to start with some crazy complex physics. You don't need a degree for this one. The answer is literally all around us, in these simple, everyday examples of a principle called action-reaction. Okay, our first stop, something we've all done. Picture a balloon you just blew up. You're pinching the end, holding all that air in, and then you just let it go. What happens? Well, here's what's going on. The action is the air rushing out backward. The reaction is the balloon shooting forward. Now here's the key detail. The balloon isn't pushing against the air behind it, it's being pushed forward by the act of throwing the air out of it.
All right, let's level up the power here. Instead of a little puff of air, imagine a super powerful jet of water from a garden hose. You know, maybe one of those firefighter nozzles.
You've probably felt this yourself, right? The action, water blasts out in one direction. The reaction, you have to physically lean into it, because that hose is pushing back against you with some serious force. It's the exact same principle as the balloon, just way more powerful. But for the final proof, let's just leave Earth entirely. This is a classic thought experiment that perfectly shows the principle in the exact environment we're talking about, the vacuum of space. So imagine an astronaut just floating freely out there. They aim a fire extinguisher away from their body and pull the trigger. The action? Gas sprays out backward. The reaction? The astronaut, without touching a single thing, starts moving forward. This is the ultimate proof. You don't need air to push against. You just need to throw something in the opposite direction. So, a balloon, a hose, a fire extinguisher in space, what do they all have in common? They all operate on the exact same fundamental rule of the universe. It's time to reveal the secret law that's been behind all of this. And here it is, Sir Isaac Newton's third law of motion. For every action, there is an equal and opposite reaction. It's that simple, and it is that powerful. This one sentence is the engine driving everything from you walking down the street to a planet orbiting the sun.
Okay, we have all the pieces of the puzzle. Let's circle all the way back to our original question and see how this universal law perfectly explains how a rocket flies through completely empty space.
So how does a rocket throw something backward? Well, it all starts with what it brings with it. It carries its own propellant. That's both the fuel and the oxygen it needs to burn it. Then, inside the engine, that stuff is ignited, creating a massive amount of incredibly hot, high-pressure gas. And finally, all that gas is shot out through a nozzle, ejected backward at unbelievable speeds. And there you have it, the aha moment. The action. The rocket pushes all that hot gas backward with immense force. And thanks to Newton's third law, we get an equal and opposite reaction. Those same gases push the rocket forward with that exact same amount of force. So this is the whole thing, the most important point. A rocket is a totally self-contained system. It doesn't need to find anything out in space to push off of. It brings its own stuff, its own exhaust gas, to push against. All right, let's wrap this all up with the final takeaway. The core concept, boiled down to its absolute essence. If you remember just one thing from all this, make it this next slide. It really is this simple. A rocket pushes gas backward. In return, the gas pushes the rocket forward. No air needed. It's a beautiful, perfect example of action-reaction. And I'll leave you with a final little thought experiment to chew on. Based on everything we've just learned, if a free-floating astronaut throws a heavy wrench, who moves more, the astronaut or the wrench, and why? Think about their different masses and good old Newton's third law. Thanks for joining me.